杂。对。所以我们在应用这样子更快、更复杂，甚至更是系统性的考虑的时候，刚才提到所有的包括散热啦，各方面都要同时进来的时候，那个复杂度呢是乘以 X 倍的。所以第一个呢，我们要做的就是人才是根本。好，那我们有了解到过去我们几十年大部分的生产的工艺很多都是在大陆，我们很多都是大家都在那边设了厂。可是当这一波呢，因为地缘政治产生一些变化之后，我们不管是拉回来台湾，或者是到大陆，或到美国、到墨西哥，我们都发现人才是短缺的。啊，因为大陆很多人，我们过去培养的一些人才呢，没有办法出来，没有办法转移。所以我们必须要重新培养。所以我们在好几年前，我们大概10几年，我们就思考这个问题，开始培养更多的人才，从学校，还有包括从把资深的人从大陆调回来培养。这是第一个。第二个，因为复杂度变得很大，所以光靠以前的人海战术解决不了这些问题。你必须要有新的思维、新的系统。所以我们从数位化，从把 AI 的这种能耐加进来之后，我们就发现呢，可以比以前用更少的人力，更有效地达到我们要做的那个结果。那这个是很重要一个关键点。你的系统、你的营运的模式要有一个相当重大的，等于是我们叫 DNA 的转变。那这个呢，是过去这几年来，我认为台湾很多我们的相关的友好的竞争者，包括 Mary 哈，其实都做很多了，所以我们大家都做了很多的这个改变。那现在更重要的是什么？我们看现在 Agentic AI 啊，是 AI 自己会去 generate， 会帮你找答案，它是一波一波，它会继续做下去。所以我们深深体会到，将来的制造一定也是 AI enable 新一波的。这个 AI， 也就是说，我们现在是 AI 的 user， 我们是制造设备，但是我们也变成它的 user。那这个 user 呢，他要善用 AI 这个 power， 把将来的制造透过 AI 的 enablement 变得更具有弹性啊，具有这个韧性啊，然后呢，在预防各种变化的时候，它更有能力，同时呢。在这个新的，不管是我们做到 rack 啦，做到这个货物端的时候，其实客户的变化度是很大的。比原来的 PC， 它现在其实还没有一个所谓统一的标准，你就做一个 box 出去，不是这样子。很多firmware很多什么都要重新调整。所以我认为呢，这一波呢，台湾的转型。绝对不是在于仅仅看到说，因为 AI 的这一波的从这个 NVIDIA 把这个。
不去看什么？因为前面有一些小互动。现在吗？对，就是等一下大家进来，应该说他们有那个拍照答案，所以他们说先不要放图片。为什么他们说10点前都不要放？可是我觉得我们可以看状况，因为。其实外面摊位只有2台电脑，然后那很快啊，真的拍完照就已经对，就一个人1分钟吧。对啊。简报笔已经有了，哦，好，这下也可以有。好 ，OK， 对，好，谢谢。 他可能要这样。小显卡，再抽大显卡。
啊，第二排是谁？
这个要问，要叫校长。
喂，我们待会才会开始，然后进来的同学可以先休息一下。场区我们这个厅是禁止饮食的哦，要记得不要饮食。然后第一排不要坐，第二排之后都可以坐。再稍等一下，谢谢。喂，我们已经就座的同学，我们可以麻烦往前坐，因为待会会有陆陆续续的同学从后面进来，那这样比较好补满，不然会容易塞成一团。如果方便的话，我们先往前坐，第二排之后都可以坐，对，就麻烦同学往前坐，谢谢。
大家先往前坐哦，然后一个一个都不要漏掉位置，因为主会场做完，其他的人就要去其他的会场。 个主持，还是用这个？
给你决定。
因为会有人要致辞，还有人要决定。
这一支的音质比较好。
那好，我就一律他们要上台讲，我就递我的这一支，然后我再接这个。
这一支不知道为什么它的声音没有这支这么的清晰。
好，那我都先用这个。
我一直以为是他们公司的。
我是东海的。
你很强啊！我还以为你是学生。
为什么？所以是。
很专业，没有。感觉很专业。
是因为从小到大都蛮。
怎么会选你来当这个司仪？
应该说公关是，因为我之前跟东海合作有台中市政府模拟人口。
这是一个很大的经验。
这个算。
那就不大。
哦，这个还没有。
几岁？23就。
我其实平常是研究人，我就做实验。
所以你现在还在读什么？
没有，我从美国，就是我原本在美国念书，但因为可能政策，我就回到美国。
国外，厉害。你有没有觉得台湾的环境不是很好？因为你喜欢外面的文化。
应该说不是，视野跟有些资源比较有限。
台湾就这样。
但台湾的便利我真的非常喜欢，便利性就是生活便利。
各有优缺啊。
对。就是你想这些资源在那边，但是绝对没有那边。
那边会很歧视。
完全不会。
是美国。
我有在德州跟密西根州。
说你待多久？这样总共加总起来
？9年、8年、9年。
啊？8年9年？
没有，就是我小时候有在那里。
所以你国中、国小、高中是在？
他大学在台湾。
那为什么大学要回来台湾？
那疫情啊。疫情。
可是你这样突然回来台湾，不会很不适应吗？
我国小就回来。
我国小就回来。
出生跟。
跟他又不一样，就是我是东海大学外包的厂商，然后厂商又有分很多个厂商，我跟他是不同的厂商。
所以你是公关？
算是，然后我们是专门当活动的一个一起，然后像你今天有什么任何的问题，没电，还是说你要订便当还是之类的，我都可以帮他写字。所以这个流程，
像之前都会有，就很多主持他们都让我参加，但这次完全没有让。
对啊，等下如果发生什么突发状况，我们会帮忙你写。
好，谢谢。
这两个就是你有什么突发状况，你就立即上来排场。像这些你都会写好吗？
我不用动，不用查。
应该是我会查。他这个电脑有点慢。
是的，他刚刚是。
处长开场的时候会来，所以就是你们会介绍一下，他不会讲话，可是要介绍一下他的工作。对。
有对，他还没有开关呢。
就有2位长官出席。
公关室，直接讲公关室。
公司处黄处长，然后还有图书处的图资长，就有2位长官，然后再请图资长支持就可以了。
好，我看一下哦。那就这个了，这件我就先讲处长，
好啊，
然后再讲他，因为他要上台。
好 ，OK， 没问题，就是要介绍到，要不然怕对他有失礼。然后再来就是他好像不会留到抽奖。
好，没问题。
对，先让你看。
对，这里邀请了公事处黄处长和图资长杨朝栋。 大家可以往前坐哦，第2排以后都可以坐。
透过我们要把这个风潮带起来之外，如果我们的内涵
变得很重要哦，事实上你着重在更加深入跟这个有关的东西，然后更重要的是你在这个 local 里面的话，怎么发挥 local 的这些所以在整个这个 我们一般在整个算力还有这个 memory 的这个 bandwidth， 还有这个 memory 的 footprint， 这里面的话呢非常重要。这里面如果能够做得很彻底，所以我才讲说 from paper to product。你如果没有把它搞得很彻底的话，你结果呢可能是 memory bomb， 结果你太多的这个 TOPS 浪费掉了啊。所以我想这些的话呢，都是必须要真正深耕，然后呢要去做出最佳的这个 balance。Hybrid AI 的话，两边到真正最厉害的时候，你还是可以利用 cloud。所以我想这里面两边的这个更加需要很强的这个 system 的这个 engineering， how to solve a full stack， 那才能够真正把它回到淋漓尽致。这个是我们很兴奋的地方。
所以换句话讲，作为一个 PC OEM， 它要做的不仅仅是一个平台，它必须要贯穿上一层的应用。Purpose build 给什么人用？他是 gamer 还是 creator？ 他来做什么用？把它上面那一层的需求，然后把它整合在一起，这样 user 他拿来用的时候是有意义的，去 support 它。这个是我想您刚刚所提到的那个贯穿，不能只做 paper， 要把那个贯穿的一部分把它做出来，才能够真正落地。
对，所以我想台湾过去当然很 proud 我们的这个 supply chain 啊，这个，但是我一直就是很有感慨，就是从 Intel 时代开始，其实真正这个吃香喝辣的是这个 Intel Microsoft， 那华硕是比较愿意，就是说从 paper 到这个 product 也下了蛮多，还需要一点点 variation。那在现在这个时代的话，你刚刚讲，所以其实不能够只是满足于，就是最前沿的那个 design 里面很重要，叫 design thinking。你如果没有在 design thinking 这边真正跟这个 desirability， 你连最源头的东西没有的话，那常常可能是牛头不对马嘴，或者说完全不听人家讲的东西。所以这个能力在台湾是特别的缺的。所以我觉得台湾为什么一直讲说，在台大的时候一直在讲说要深耕细，深耕细。包括台大最近在很多的 paper， 我想你看现在最大陆实在太强。所以这个是我们要很谦虚，要很就是该有报现实的报现实，然后赶快把这些东西补起来。台湾还有很多现成的这些有利的点，那这样的话就没有办法去对付这样的一个。
所以总结来讲，我们今天听到这个在座3位来宾。有一件很重要的事情，就是说台湾的优势是我们的基础的建设系统，但是同时我们要这个垂直的领域去深耕、去突破。我们有不足的地方，不管是应用场景，还是解决方案，还是跟第三方的合作，在开放平台，我们都必须要更宽阔的这种方式去拥抱、去挑战。因为这个在未来的机会是无限，尤其是在这个 physical AI， 我们要去把握，这是一个非常重要的部分。非常谢谢各位3位来宾的分享，今天谢谢。
AI 是人类有史以来最强大的工具之一，它让我们学得更快，创造得更多，能解决更困难的问题，更能把梦想变成现实。而 AI 已经开始真正的动起来，它会推理，会使用工具，甚至能跟真实世界互动，能够自己规划、整合跟随时调整的 AI agent 推动下，台湾的工厂、机器人、供应链变得更聪明，也更强大，而且永不停止脚步。
The age of AI agents is here. AI agents represent a significant economic opportunity. They will be integrated into every industry, changing how companies operate and how work gets done. The next frontier is physical AI. Systems with a body that can perceive, reason, plan, and act in the physical world. Taiwan's manufacturers, automation leaders, and robotics companies are using agents and physical AI. This will usher in a new era of robotics, where intelligent machines become an integral part of every industry and everyday life.
台湾的制造业者已经把 AI 代理人实际用在工作上了，打造出智慧工厂、仓库、工业系统，还有机器人。接下来有3位实际把 AI 带进工厂的3位主讲要加入我们。第一位 Casey 杨，鸿海科技集团 AI 软体负责人，也是集团史上首位女 CEO。
大家好。
童子贤，我想大家都认识合作联合科技集团董事长兼首席策略长。蔡文章，台达电总裁兼营运长。那我们刚刚讨论很多这个机器人，那我想 Casey， 你站在这个产线、仓库跟全球供应链的第一线哦，我想你比所有人都清楚工厂到底现场长什么样子。那我听说鸿海最担心的不是 AI 太贵或太难，而是你们够不够快，能不能满足这个 AI 的这个需求？对，对于你们来讲，把 AI agent 放进每一座工厂。每一条生产线到底最难的是什么？那这件事情做完了之后，这个制造，这个制造会是现在的制造，还是整个制造会有完全不同的定义了呢？
好，那个不是我说实在的话哈，在我们去导这个 AI 进到智慧制造的时候，坦白说，我们的担心可能比导入之后还要高。反而是导入之后，我们都松了一口气。其实我们在2年前呐，我们就已经呢开始在做这个智慧制造，而且我们导入一个专案叫 GTC。这个 GTC 这个中文叫创世纪。所以我们对这个专案期望高了哈，就希望它能够这个不一样的这个制造的世界。那通常呢，这个有这样的期待之后呢，这个看它这个 Gen 哈，我们又把这个 Gen AI 呢当它的一个这个导入的主轴。那我觉得呢，先跟大家讲的结论好了。3个是给大家。第一个，我们现在排线的产能效能提升50%。然后呢，我们的误判下降50%。然后呢，我们的这个就是异常的真因分析提升精准率到90%。那大家就会很惊讶，我们怎么做到的？其实跟大家说哈，我们其实做了3件事。第一件事情哦，很多人会想，哇，我要导入 AI， 我一定要先赶快搞进很大的这个专案。其实不是，第一件事情一定要把资料收集好。所以我们呢，在第一件事情，这个是我们刘董事长非常有远见的地方。他要求做什么呢？先把会议记录都收集好。过去年来的会议记录都先收集起来。所有在异常问题所发生任何的异常的过程处理的流程记录收集起来。我们发现这个事情做太对了。今天回头来看 ，data 最重要。第二个是什么呢？你不要期待 AI 马上帮你做天翻地覆的事，所以你要把它放对位置，你要让它真正的进入什么呢？你的 workflow。而且呢，第3个是什么？看到对的点、痛的点、合适的场景，你就赶快进入。你不要再等。所以刚刚就是讲嘛，我们其实担心的不是怎么导入，我们担心的是够快。所以呢，在这2年，我们用非常快的速度导非常多的用力，而且这些用力现在都用非常的成功。我举一个厂长的事给大家听哦。厂长的这个工作是什么？他就叫保质保量，对不对？每天所有的产他要交完成。可是呢，讲得很简单，那大家知道吗？他每天早上进来，他要开多少会议？有多少面生管、品管、材料要开会，才能确保我们可以达成这个效益。但是现在不是，我们导入了一个叫 GTC AI， 这个一导入进去之后，现在不能说轻松，常常会这个但是呢，基本上他现在早上进来喝杯咖啡，就能够把所有资料全部看完，让他做决策。所以我要讲哦 ，AI 并不是要代人，而是 AI 要让人可以把时间花在更有意义、更有价值的地方。所以我想这个是我的回答。
太棒！我想这个 AI 的制造起来，让你做更多事情，更大的工厂。
是。好，那么我接下来想请教这个董事长哦，这个 GTC 已经从这个数位的世界进入到这个实体的这个物理的世界哦，那它可以进行推理，它可以产生行动。那您认为就是说，在未来的工厂的生产的过程当中，有哪一些环节会因为使用这个 GTC 来带来最大的一个利益？
我想那个过往的工厂呢，大家都知道有大型的工厂其实是非常的复杂。你会感觉刚才所提的从生管物料到实体制造有很多复杂的事情要解决。那我们先抛开过往，我们来有一个这个期待未来是怎么样啊？我们有天在描绘一个未来的世界啊。当 工厂呢，它采用的 agentic AI，agentic AI 跟 physical AI 结合的时候呢，工厂不再是旧的非常辛苦、非常混乱的这一种状态。它会变成非常有秩序，错误非常少，效率非常高，决策非常有逻辑，有流程非常清楚。当意外发生的时候呢，agentic 的 AI 呢有能力去帮你解决。我们来举例来讲，旧的工厂现在赋予它 agentic AI 的这个软体环境之后呢，它有感测器。它的感测器感测到某种状态的时候呢，它也会做出判断跟决策。这个时候，如果你的工厂里面还有一群 physical AI 的那个人形机器人的话呢，它本来在从事替代人很辛苦搬运轮胎，拿那个很重的扳手在锁很重的螺丝。当一群这个robot 走过去的时候呢，工厂的 agentic AI 会跟他沟通说：“你们这几个啊，暂停一下，我发现工厂的某一个地方的变压器有一点过热。这个时候工厂的 agentic AI 会协调 robot 呢去巡视跟检查。”那偶尔也有一台可能也可以派出一台无人机，这个无人机也具备 AI 能力，它其实也是一个这个 robot 一种会飞行的 robot， 它可能可以飞到某一个角落去检查哪一个故障的零件，然后通知机器人去帮它修复。那像这样的情形以往听起来好像科幻场景、科幻小说，再过来不是了那我引用我们以前这个念佛的人会讲说，人可以跟这个世界沟通，是因为你有眼、耳、舌、鼻、身、意你的眼睛、你的耳朵、你的舌头、你的鼻子呢，都是你的感官，跟物理的世界、实体的世界接触。可是那个意呢？那个意就是你的 LLM 你有这个眼耳舌鼻身之后呢，透过这个意去跟实体世界沟通。那这样就摆脱过去3年来我们在用generative AI 的时候呢，其实只有耳朵，它听得懂你的自然语言，它也有思考，也有脑袋。他也有嘴巴当他把他思考出来的结果用嘴巴告诉你，也是用自然语言，但是他缺少什么？他缺少手跟脚跟身体。好，现在 physical AI 补足了眼耳舌鼻身意这一块未来的工厂，它的效率高它的运作有秩序，它可以让人也减轻很多体力的劳动目前的定义是这样就是 robot 呢，它会大量的这个机器人，它会取代人类最繁重、最耗体力的工作。所以一个理想的世界应该是生产力很高，大家又不要那么辛苦这是一个理想世界。
这里面来讲，还有一个重点就是说，它是让我们人的技能也在转型，我们把我们的技能放在最重要的工作上，让我们的工作更有效率，生产力更好。那机器人它可以多工 ，OK， 它可以做这个，可以做那个，而不是单一的事情，所以它非常的灵活。
我们在讲agentic AI 有些人都会直接把它联想到机器人其实机器人，也就是说所谓的这个被 embodied 的一个 AI 呢，我们在讲无人自驾车，其实也是一个装上轮子的智慧机器人达文西一个这个开刀的这个手术的下一代的这个达文西呢，其实就是一个机器人波士顿的Dynamics，它有做那个4只脚的机械狗。当你要去救灾，当你要进入一个危险的这个工地的时候呢，你可以先派机械狗去。它其实也是一个狗型的一个 robot 也就是说，刚才举的例子，无人自驾的计程车跟机械狗跟达文西，它们其实就跟 robot 的人形机器人一样。都是 physical AI， 这个 physical AI 配合上像最近半年非常流行的龙虾 那龙虾就是说它是一个软体，可是你会发现它可以替代你滑鼠、打键盘跟自动下单买股票。你把刚才的这个 Physical AI 跟龙虾这样的Agentic AI 结合的话呢，未来人类的生产力会非常高，不会停留在以往只能替你泡咖啡。
是。我想这个还是要回到一个最根本的问题啊，就是说这个要支持这么多的 AI 的发展，我想电是一个非常重要的一个问题啊。就 Simon， 就是说现在看起来这个其中一个很大的挑战是怎么样把电一点都不浪费，又稳定的送到 GPU 的旁边，送到 XPU 的旁边哈。那 Delta 在这边很特别一点，是从电网等级的电子设备一路到 chip 端的这个电源模组。从 Grid 到 GPU 也是另外一种形式的端到端啊，就是这个全世界很少公司可以做得到。那我想说，你要怎么样利用这个优势，在整个 AI 能源时代的这个基础建设里面扮演更不一样的角色？
我想台达在做这个电源的产品线的时候，我们很早就开始规划从电网到chip。所以有很多现在看到的产品都不是今天端出来的，是已经默默的做了5年10年了。比如说像现在在谈8版，这个早就已经开始。下一波要用固态变压器 SHE 取代传统的细钢片的变压器，这个应该会在这1-2年，最慢00年就会爆发。这个时候。整个电机系统，它变成是可调可控，在过去传统的 AAC 是可调不可控，那改成 SHT， 从中压、中高压一直变化下来，它是可调可控，它可以适应这个 AI data center， 它的 loading 是 up and down 非常的厉害，所以传统的电源系统它是要用很多的电容器、电池来做瞬间的backup，那它没有办法，传统变压器没有办法做调整，但是 SHT 可以。那经过这样子就会让整个端到端的效率有效的提供，而且我们可以看从中压一直到0.几伏，这中间要变换很多次，每变换一次，它的漏时就会增加很多。那如果导入 SSD 以后，中间有很大一块的原来现在的产品会不见了，所以它转换的次数变少，效率会大幅提升。那很多人这样讲说，你这样子是把自己的产品杀掉吗？我觉得不可以这样考虑，因为这个是趋势。如果你不站在趋势的浪头，第一顶这样子的一刀切取，那你等别人做下花了，那你丢掉的不是既有产品，是未来的整盘棋，整个市场都不见了。所以台达在这个电源系统里面，我们真的是有很多单位在做啊。那除了这个电源之外，还有提供很多的这个散热啊，因为只要有漏水，它就会有热。那唯有电源系统加上散热系统，你才可以发挥整体的效益。我想台达要做这么范围这么宽的产品，我们已经不跳脱传统的这种产品디자인的经验，我们把 AI 导入设计阶段，里面有一个大的program叫做 Smart Design， 从 AI 用大模型开始review市场的 information， 然后客户的规格，然后 safety 的要求、法规的要求，都会让 AI 帮你做上来，要不然你还要花很多的时间去读。那这个读规格不是他的专业领域。那接下来我们把所有的电子元件、电路或者是整机都建成 digital 的模型，数位化模型。那在还没有做硬体之前，就在摸索的环境里面不断的迭代很多次，找到最佳设计，才开始制作样品。那样品出来以后，就很快的验证你的 simulation 跟你的硬体之间差异有多少。那最后的 testing 也都是可以在 virtual 里面完成。所以我们现在可以讲说，未来会用 AI 的公司才有机会，因为 AI 的公司可能会退出市场，因为我的预测啦，整个 design cycle 可以最少减少50%， design cost 会少也是50%以上，因为你所有的 try and error 在 computer 里面，它是只要 token 付钱就好，其他都不用付钱。然后出来以后，马上它的这个规格或者是生产条件，它也会产生出来，所以跟我们的 smart manufacturing 定格在一起，所以让产品进入产线的叫做 model introduction， 就 NVIDIA 的流程会大幅缩短。会让产线很快的接上来那整体的效应大幅的提高。所以在台达的整个企业活动里面，我们有几大主题，一个就是 Smart Design、Smart Manufacturing、Smart Quality 然后试着把整个台达的制造业的完整的 process 都让 AI 来辅助来帮助我们，让效率整个提高。
你看台湾的这些制造业真的很厉害，都已经把智慧的制造都已经融入。我想各个三家公司的工厂里面都有很多协作机器人。但是 Casey， 我想问一下，你们好像已经把工厂的机器人往新的这个 vertical integration 去做，比如说听说你们在医疗方面也做了不少这个协作的机器人，你要不要跟我们多讲一点，怎么样从工厂你本来最擅长的工厂管理生产机器人往各种不同的应用来做呢？
好，我觉得我们在谈机器人的时候，先绝对不要忘记一个很重要的这个解决方案，就是 Omniverse。这个我要讲这个 Omniverse 真的是 amazing 啊！他在专门解决什么问题，大家知道吗？他在解决那个千金难买找到。很有趣哦。那个其实哦，因为哦，在没有 AI 之前啊，你的试错成本其实非常高。所以呢，我们如果有很多的异常工作，工程师他如果这个没有办法提早知道或解决问题，那他常常会告诉自己，我早知道做就更好了吗？但是现在有 Omniverse 之后啊，它不是只是个模拟工具，这个 Omniverse 它现在帮助我们在工厂说这个所谓的硬体、软体、overflow， 包含整个环境，包含我们在做这个 AI 的这个 server rack， 我们是很热的哦，这个需要热对流的模拟哦，这个 Omniverse 全可以帮助。所以我们呢可以在虚拟的环境不断的做模拟，不断的做训练，不断的这个就是学习，然后不断的优化，当它达到一个最佳效益化的时候，我们再把它放到世界去。所以我们机器人也是一样，我们机器人呢。不是没有训练就把它倒到虚拟世界里面去，一定是把它先放在虚拟世界里面去做很多的训练。所以我们现在用 Omniverse 我们在做这个建厂跟产线的设计啊，还有这个部署按照我们现在最新的这个规划哈，还有实际的验证来说，我们现在大概时间缩短60%以上。这是个非常大进步。我们现在的机器人在美国已经实际上可以做到什么呢？它现在可以做到 pick pack， 然后它可以做到简单的组装、锁螺丝，这些可以做。
大家把所有的空位都补满哦，旁边有空位都可以坐哦。因为我们今天有分2个场地，所以大家能坐在这个场地是非常 lucky 的。各位同学、师长同仁早安！活动将于5分钟后开始。提醒您，本活动会场禁止饮食，如果有用餐的需求，请于场外。由于今天报名的人数较多，场内座位有限，所以请坐的时候一个接着一个，中间不要有空位。今天活动会凭大家和 NVIDIA 任何制作物打卡上传，并且要 hashtag 上传确认，享有抽奖的资格。所以大家今天不要吝啬的多拍照哦。欢迎大家一起参与 GTC Taipei 2026 NVIDIA 执行长黄仁勋执行长主题演讲直播。全台湾共计有20所大学参与了此主题演讲直播派对。NVIDIA 致力推动于 AI 的进步，并积极学术机构互动交流。今天呢，由东海大学校园的 Watch Party 汇集了对于 AI 未来充满热情的同学们及师长同仁们，一同观看 Jensen 的直播。直播结束后，还有令人期待的抽奖活动，大家想不想中奖？在这大家想不想中奖？对，今天总共有3个奖项，然后礼物都是非常的 special 跟丰富哦。好，今天我来介绍一下今天的奖项。今天呢，除了有 NVIDIA GeForce RTX 50系列的显卡， 合作伙伴 ASUS 也有提供了一个人独拿4个背包，4个，就是 ROG Archer、ROG Ranger 电竞后背包，以及 ROG/ 单肩包，还有 ROG/ 后背包。对，所以大家一定要记得拍照打卡，还有带证件哦，因为我们的奖项的金额较高，所以需要带证件跟其他的详细内容。好，在今天这个特别的活动里，我们也特别邀请到了副校长刘正副校长，以及图资处杨朝栋图资长，和国际长廖敏勋国际长，以及公事处黄兆喜处长，还有推广部蔡坤林处长，以及农学院林鹤院长。好的，现在我们就掌声欢迎我们的副校长刘正副校长上台为我们致辞。
好，我们图资长还有学校的各位主管哦，还有我们 NVIDIA 的 Lin 哈。还有最主要是在座各位同学，大家早安，大家好。其实我想了一下啊，最近有什么热门的新闻啊？可能大家有印象的就是台大的有一个毕业生，然后跟大家分享他在台湾学习的过程啊。那其实最让我感动的是，那个他在台湾给了他一个家啊。我们看到一个台湾太太，还有一个小卷毛啊，其实让人觉得是非常温馨的。我不确定大家有没有印象啊？其实最近还有一个蛮热门的新闻发生在同学们身上啊，就是我们有一位同学，他要请假，跟老师说：“老师，我要去股市开户。”老师马上跟他说：“准假哦，马上准假。”但是我要跟各位同学们讲的是，等一下的1个小时里头啊，大家不要只看股票哈，重点是你要知道要买什么。等一下的1个多小时里头，重点是你要知道黄仁勋讲了些什么，让你们知道以后要买什么，这个比较重要啊，不是你去开户啊，开户有什么用？开户你不要买中钢，你要知道要买什么。这样 OK 吗？中钢是我那个年代在买的，好不好？那今天我还是要借用大家的双手哈，我们要来谢谢我们的图资长，还有我们的图资处电算中心这些同仁们，因为这些时间以来，我们做了真的好多的事情。我们谢谢图资长啊，我们谢谢我们的副图资长啊。还跟大家提一件事情啊，今天大家有这样的机会哦，我们跟 NVIDIA 黄仁勋他的演讲来做直播，这个是3年以来一直持续办理的活动，这个是全台湾仅有的。那图资长还特别告诉我，从苗栗到嘉义，东海是唯一的学校。我们知道啊，有一些学校今年加入了，所以在大做新闻啊，那个缝插夹这个很无聊啊。第1年在大做新闻，再跟大家讲，还有一个学校今年前一阵子刚筹办了，刚建制了第1间的 AI 教室啊，哇，新闻播得好大啊，那个我们估计那个新闻媒体花出去钱大概有几百万，为了播报那一个新闻。大家知道东海大学现在有几间建制完备的 AI 教室吗？给你，我这个就送你了。你老师不算了。来，在座同学们知道吗？你刚刚讲几间？4间，那你太瞧不起我们图资长。告诉大家，7间呐， 大家有听过什么新闻吗？其实东海大学多少年来真的是乐色寡言笑啊，我们是很谦虚的啊。那默默的在做很多为高等教育服务的事情，但是有这样的好活动，我们学校有这样的好校长，有大家这样的好的行政主管，有好的老师们，请同学们真的要多多利用，然后多多学习。谢谢大家，祝福大家啊！
好，再次感谢副校长精彩的致辞，也请副校长先行回座。好，现在就是我们的大合照时间喽。对，然后我们会有分2个部分，第一个部分就是我们的动态摄影，第2个才是静态。然后再麻烦大家可以集中哦，想要入境的同学。因为拍摄只会到中间的部分，所以想要入境的可以站到走道上。好，那就请大家都移动，来，大家都2侧的同学都起来，请移到往中间靠。然后有拿到手举牌的同学，也可以把它露出来。然后脱口罩的同学可以先行脱下。来，大家移动哦，同学。好，看中间那个最大台的，大家请移动哦，尽快。来，这是动态哦。哦，动态者，所以先静态。好，先静态，不要动哦。3、2、1，起！赞！ OK， 好，现在就是动态喽。他们要做什么？吗？哦，好。好，我们再喊一次啊！东海大学赞！大家都好冷静哦，是因为太早了吗？大家起床喽！好，那尽快回到座位上哦。大家要保持清醒啊，等一下好好听演讲哦。OK， 接下来让我们掌声欢迎 NVIDIA 的 Ellen 上台。为大家针对再次报名提出的问题来分享与解答，而且他问问题的时候会有礼物哦，所以大家要仔细听、仔细回答。
谢谢。嗨，各位长官、各位同学们，大家早安！我是 NVIDIA 今天的代表 Ellen 但我知道就是大家可以比较好记的话，可以叫我 Ellen， 就是冬天大家会冷的那个 Ellen。那今天很高兴代表 NVIDIA 来跟所有东海大学的同学们啊，还有老师们，各位长官们一起共襄盛举。那我刚刚有听到，其实东海已经办了，今年是第3年了。有谁连续3年都有来的吗？这个老师不算，后面的工作人员也不算。好，那看起来我们蛮多新血的。那等一下，希望大家不管怎么样，都可以认真的带一点点的资讯回去也好。像今天呢 ，Jensen 他就负责 technical 的部分，我们技术啊、新产品，我们等一下就认真听他说。那今天刚刚 Ann 也有提到，其实我们这次来，我本人今天没有要讲产品交给 Jensen。那我相信大家对 NVIDIA 一定有很多的好奇跟幻想，所以在这之前呢，老师们也有帮大家收集了一些对 NVIDIA 的提问，所以我们有从中选了3个大家最常问的问题，然后今天来这边做回答。但在这之前呢，我想要先调查一下，今天现场是认真想要听 AI 啊、NVIDIA 啊各种趋势的，请举手。不错哦，这一群有点慢哦，我不确定是真的假的。那有谁是陪我一起来啦？被朋友抓来了，完全不知道在干嘛的，有吗？好，不要举手。那应该也有一些同学们是为了 抽大奖来的吧？5080、5090，5080、5070，有谁想要的吗？那照片呢？都拍好了吧？都打卡了哦，身份证都带了。好，等一下没带的可以偷偷跑出去，赶快回去拿。好，那我们就赶快先开始我们今天的第一个问题，叫做我要如何不被 AI 取代？那再调查一下，今天在这边今天来的同学们的科系，就是2类组，资工啊、电机、机械、data science 相关的有吗？比较少我有点意外。商学院的呢？商学院的，文组的，那个兽医3类组的，不对啊，都没举手，还是跨领哦 ，OK， 大家有斜杠是不是？不止工作有斜杠，现在大家有双主修，好，那。哇，那这样子来，那我们第一个问题，觉得自己的科系跟未来的工作不会被，我们先问，觉得自己会部分的工作会被 AI 取代的，请举手。那觉得不会的呢？不会的，有同学来，请问你叫什么名字？然后什么科系？然后你觉得为什么你不会被 AI 取代？
我是叫王家安，我是政治系的。那我认为政治是一个人文跟国家发展的基础，所以它需要一个负责任的一个表征，跟会计一样，会计本身是为了负责任而存在，不是为了计算而存在。所以我认为这类的工作难以被 AI 取代。
哦，非常好，一个奖小礼物。还有谁想要分享吗？觉得自己不会被 AI 取代的，有吗？有吗？没有，大家都这么害羞。没有吗？真的没有吗？好，那其实我觉得刚刚同学有讲到一个很重要的一点，他说负责任。其实 AI 有一个东西没有办法被取代的，就是人本身的很多的特质。那这个特质呢，我们可能等一下可以再举更多的例子。那下一个大家醒来咯，下一个题目，请问大家一定都听过 Jensen 讲过一句话，因为他常常被问这个问题嘛。那他说过 ，You're not losing your job to AI, but 什么？他说你的工作并不会被 AI 取代，但是有人知道吗？来，请说，大声给他讲出来。没错，他说 You're not losing your job， 请帮我把那个礼物送给我们的同学。他说 You're not losing your job to AI, you're losing your job to someone who uses AI。所以其实 AI 它并不是一个会取代你的人，它在帮助你。你们其实不要把 AI 想成说它是我的 competitor， 它是我的竞争对手。确实 AI 它现在可以处理很多海量的数据，然后它可以去帮助大家执行一些复杂性高一点点，或者是重复性高 pattern 多的工作。但实际上 AI 还是有很多事情做不到。就举例来说好了，以我自身经验，因为今天问的这些问题，我觉得就是公司派我们来这边也是希望可以跟大家分享我们自己的感受。那 AI 没有办法取代的，有一个举例来说，比如说今天你老板从你走过来，然后跟你说，那个下礼拜董事会帮我准备一个简报，就关于 generative AI 怎么样对半导体产业产生一些影响的。这时候你们要怎么办？有人平常都在使用 AI 吗？你们平常使用 AI 的情境是什么？有人想要分享吗？同学，我们换一个，有吗？有吗？我们还有小礼物，有，后面有一个那个蓝色外套的。
AI 现在其实运用的很广泛。那如果以我们理工科系的人来讲的话，我们比较常会拿来做程式的除错，或是就是计划的发想等等之类的，还有很多其他的，就是也有看到网络上很多人直接用 AI， 然后去创造程式，直接去设置一个 App 等等之类的。
很好，我们谢谢这位同学，再帮我把小礼物递给他。对啊，其实刚刚同学都有同学有提到，那我再调查一下，没有在用 AI 工具的举手。不可能，我不相信，是不是？大家一定多少 ChatGPT 免费版都会丢进去问了吧？所以其实大家都在使用 AI 了，所以你已经在使用 AI 的路上了，所以你就不用担心。只是接下来你要更加去精进自己的部分是这个。那我们刚刚提到，就是老板可能突然叫你做一个简报，你最快时间是什么？ 我丢到 ChatGPT 里面，5分钟它给你生出来20页，这个大家都知道嘛。但是重点在于，今天老板到底想要听什么？比如说，他不会知道你的 target audience 是谁，你的老板到底最在意哪一页？董事会到底想听的是未来，还是投资风险，还是未来3年会不会有任何其他的机会？那再举另外一个例子来讲，刚刚有2类组的同学嘛 ，maybe 以后就是会，比如说像是工程师或者是写code相关的，那甚至 maybe 会有 PM 之类相关的这种工作职能的发展。那像 PM 的话，你可能今天客户跟你说，我想要加一个什么什么什么样的需求在我的产品里面，那你第一件事情要做的就是，对啊 ，AI 可以帮你去分析这个需求，然后去帮你甚至写详细的规格书，但他没有办法做到的是，今天你这个 PM 你需要有自己的 judgment， 你要做的事情是，你要先分析现在这个时间点生产这个产品会不会影响到我的其他的产品规划，那它会不会排挤到我其他 R&D 工程师的 resource， 这些都不是 AI 可以告诉你的。AI 甚至 maybe 它可以帮你们排行程表等等的，但是它只会告诉你说，今天这个 project 有没有 delay， 今天的这个 progress 是不是有 on the track。可是很多东西最后还是需要你们自己去人跟人之间的沟通。像刚刚还有提到的工程师嘛，写 code 写完之后进 production， 但是 production 半夜挂掉的时候谁要负责？还是人啊，最后要出来 trade off， 要出来 fix， 然后要出来去改善这些东西的人，最后都还是会回到我们自己。所以有一个很重要的一点就是呢，我们在做 AI 常常需要我们的指令去做更多的事情，所以我们要做的事情应该是去成为那个可以给予指令的人，就是你要去 frame the problem， 也就是说 AI 它现在可以帮助你非常多东西。可是实际上你需要了解的是问题本身的重点。刚刚其实在 pre-game 的时候，有一些来宾就有提到，其实最大的重点就是你要知道你的 pain point 是什么，那你才能够真正的去了解问题的背后的意义，然后再去做改善。那下一个问题就是大家一定很好奇 NVIDIA 的工作环境啊，还有经验。我自己这边的分享是，其实 NVIDIA 是一个速度非常快的公司，然后我们公司自己有一个 core value， 就是 speed of light， 它的意思就是说我们速度要非常的快，我们要非常的敏捷。这个敏捷不在于说我做什么事情都快，但是没有任何的精准性或者是效率，而是他希望我们可以非常的敏捷、非常的灵动去应对很多的事情。那在这之中呢，你很敏捷，但是你还是大家可能瞬间多头马车会有出现这种状况嘛？那到底要怎么去改善呢？还有一个很大的重点是，对我们来说，你们一定会觉得哦 ，my manager is the boss， 就是我的主管才是我老板，但不是，在我们这边 mission is the boss， 就是我们的重点，我们的目标就是一个。那今天到底这个目标严不严重，或者是这个目标是需要一群人一起去完成的。那在这之中呢，这个 mission mission is the boss 也会让我们变得比较的大家会很 open-minded 的去讨论这些事情，所以就比较不会有，比如说因为我的主管挡了我，或者是别的部门的谁说了什么，然后就跟我们说啊不行做，因为我们最终的目标是客户真正在乎的是什么，然后现在这个世界上到底缺了什么，我们需要去做更多的调整。这是我自己的一些工作环境还有经验。那最后一个问题就是大家一定都很好奇，有人今天包包里面已经先写好履历，打算等一下一结束就递履历的吗？应该OK， 因为我们我今天不收履历，但是等一下会有一些小管道可以分享给大家。在这之前，我们再提问一下，有人要猜我是什么科系的吗？因为这里问到了嘛，什么样的经验可以什么样的经验或者是主修的限制？有人要猜气管吗？不是。还有吗？资讯科学不是。 外文系，没错，我是外文系的，我也是。我以前也在台中读书啦，我是中兴大学的，我是外文系。然后，大家没猜到我现在在 NVIDIA 里面做什么？我不是 PM， 我不是 PM， 是不是有点难猜？我还有小礼物吗？还有2个，先帮我一个给这位同学，因为他非常的热情，他很主动，一直在回答我问题。有吗？有人要猜吗？发言人，谢谢你，这表示我今天做得很好，但不是。公关，我不是公关，但是我的工作大范围的去讲，底下是有公关的。没错，我是行销。然后我们最后一个礼物，这边，对，我是 marketing 的，然后我自己现在在做的叫做 partner marketing， 就是去管我们的 partner， 比如说，不要用管，对不起。去跟我们的 partner 合作，就是比如说像是华硕啊、微星啊等等的这些 partner， 所以大家刚刚陆续都有猜到嘛。其实我是外文系，然后好简单的我去了我外文系，然后后来去了华硕实习，然后在华硕工作，然后后来来到了 NVIDIA。我觉得以我自身的经验还有学习历程来讲，其实可以蛮明确的跟大家讲说，我觉得不只是 NVIDIA。很多工作它是没有限制，很多的限制是你给你自己的。那只要你愿意去学习的话，这些东西都不会是个问题。尤其我觉得以 NVIDIA 来说，就那时候我去面试的时候还很年轻，大家应该看得出来我应该还是蛮年轻的吧。然后，但就你就会想说，这么多那么优秀的人。然后他的工作经验可能比我还要多，非常非常非常的多。那到底为什么 NVIDIA 需要我？为什么 NVIDIA 想要用我？那我觉得有很大的一个重点是，每一间公司在用人的时候呢，他都会看你们自己的潜力。我觉得 potential 是一个很重要的事情，还有你学习的速度有多快，你吸收的速度有多快。所以我觉得大家呢在这里都不要给自己有太多的限制，我们只要尽可能去做。我觉得甚至你不用说一次就要设定很大的目标，你从一步一步慢慢开始都是一个很好的事情。那在这边呢，我们就是简单的分享一下，大家可以扫这个 QR code， 上面会告诉你们有一些什么样的资讯可以去 reach 到人资，然后我们也有一些 program。然后，如果真的有大家真的很专注的在研究，或者是想要了解详情的话呢，其实都可以 follow 我们的 LinkedIn 啊、Instagram 或者是我们的 blog。然后我自己建议就是可以常看 LinkedIn 啦，尤其大家有看到那个 Jensen 前几天在那个 Constellation 的，就是他说我要再招3000名员工嘛。所以我觉得大家都是有机会的。好，那今天就是我的 sharing， 感谢大家，然后希望大家等一下认真听 Jensen 的 keynote， 然后不要离开，因为我们等一下就要抽大奖了。谢谢大家。
好的，我们再一次感谢 Elin 为我们带来的分享。好。稍后11点的时候，就是大家最期待的 keynote 演讲直播。那在此之前，大家可以稍作休息，上个厕所，因为等一下就来坐着抄笔记、写笔记、听演讲喽。OK， 去吧，休息一下，休息一下。
I've been counting out, left on red, left and out. Every maybe felt like never, but I kept your picture in my wallet. Folded corners, I saw it. Every time the world said whatever, I can get that tightness in my chest when the floor drops out on rest. I just breathe and move step by step. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands stop bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying. Never gonna stop trying. Friends turn strangers overnight. Dreams went quiet, lost their light, but I learned to go in the shadow. Talk to mirrors like a coach, get back up, that's all she wrote. So I run through every high, every hollow. It's in my chest, but this fight don't accept any end. It says regret, not yet. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands start bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying. If I fall tonight, I'll rise. All my failures on my side, like a choir for my life, singing one more time, one more time. I'm never gonna stop trying, even when the waves keep rising. You can see the fear in my eyes, and still I'm standing. I'm never gonna stop reaching, even when my hands stop bleeding. Every little scar is a reason I'm still standing. Never gonna stop trying.
好，各位，再过3分钟 ，NVIDIA 创办人暨执行长黄仁勋执行长在 GTC Taipei 发表的主题演讲直播就要开始了，请大家尽速就座，并将手机调整为静音或飞行模式。
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge, reason, action. They reveal patterns in complexity you could never see. Mirror our cities to keep us safe. And lift us high above them. Tokens help robots learn from us. Work alongside us. They go where we cannot. Lending us helping hands. And closing the gap between hope and healing so that we breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground on a scale never attempted. So we can reach
Star Cloud 1 separation confirmed.
to infinity and beyond. Together, we take the next great leap into a bright new future, built for all mankind. And here, in Taipei, is where it all begins.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO Jensen Huang.
大家好 Welcome to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad. And a round of applause for our pre-game show, Superstars, ladies and gentlemen. Look how adorable they are. The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan. 70 different conferences are going at the same time. Everybody is watching this keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here. I mean, there's so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem. The richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding. One of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months, in the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is impacted, is generated by $3 billion worth of salary. That $3 trillion, that $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer, and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units. Tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. Inside, this is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model, or many, sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrates this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that you can act, that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system. Okay? And so this is the new computing model, and this is what an agent. It can do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools. We can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codex does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to NVIDIA I logo, then scatter and repeat. Right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool. Create a CAD file. Ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years we've been building towards this, and now it has arrived. Now one of the big breakthroughs, of course, is tool use. A lot of people have said, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough, and in fact what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them CUDA-X libraries. This is NVIDIA's treasure. Today, we're able to now present these CUDA-X libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for CUDA-X libraries. Let's take a look.
20 years ago, we built CUDA, a single architecture for accelerated computing. We reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. CUDA-X libraries are tools for agents. cuLitho for computational lithography. cuOpt for decision optimization. cuDSS for direct sparse solvers. AIQ for deep research across structured and unstructured documents. Ariel for AI RAN. Warp for differentiable physics. Parabricks for genomics. At their foundation are algorithms, and they are beautiful.
A round of applause for math. Math is beautiful. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales. And each one of those steps are running in a different part of the computer. And you can see The large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with the large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated users of tools, which is the reason why the CUDA-X libraries that I showed you are going to be incredibly popular with agents. They solve some of the most important problems the world knows. And all of our CUDA-X libraries are now going to come with skills that the AI could learn how to use. So the CUDA-X library, some skills, basically a manual, the AI reads it and go, aha! That's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called the DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you can see, every aspect of this computing model, this computing pattern, this new application called an agent, is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason. This disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation, Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with the GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin. From end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called Doka. The security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers. Not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle, and it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company. But over the years, we've evolved to become a systems company. You're looking here now for the most complex systems, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack, just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex, every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end, because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout, simulate the power and cooling, design the network, validate every integration, test every change in the digital twin. The factory powers on. DSX OS takes over and provisions, operates, monitors, and remediates the infrastructure, turning the installed systems into trusted, multi-tenant, resilient AI-ready capacity. Today's AI factories over-provision power by up to 40%. DSX Max LPS lets operators safely deploy more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts, sending them where work is happening. In-rack power smoothing flattens peak current spikes and power surges. Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance cooling and power to meet workload demand. DSX AI factories are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
I've shown you ecosystem slides of the past, where NVIDIA's computing layers and software and computing stacks are integrated into other people's platforms, third-party platforms and libraries that serves end markets. That was a computing ecosystem. This is an AI factory ecosystem. This is way downstream of all of you. Upstream of me is all of you, and downstream of us is this ecosystem. Because NVIDIA ultimately is not just building a GPU, not just building a system. We're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $30 billion. It is at $50-60 billion, and soon it will be $80-100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, we used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true. so that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem. We call it DSX. RTX is for our GPU, DGX is for our systems, and now DSX, basically infrastructure. Because of the work that we do here, across this entire stack, including our systems and software, it's the reason why we can work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth 50, 60, 70 billion dollars and growing incredibly fast. Recently we worked with Nebius, and again, they're growing incredibly fast. Each one of these clouds have incredible customers. Cursor, the software coding company, Black Mountain Labs, Image Generation, World Labs, World Foundation Model, Revolut, the leading financial services AI company, and Shopify. Here's another one. This is Nscale, and their customers are British Telecom, Google. Google is using one of our AI clouds, Thinking Machines, a Frontier Labs company, super exciting. Here's Naver Cloud in Korea, Bank of Korea, Hyundai, so many incredible companies. Here's one in India, Yoda, incredible companies. Here's one based in Singapore, building in Australia, Together AI, AI Singapore. This is one in Indonesia. Each one of these companies are serving regional as well as global customers. AI is going to run everywhere. Every company will be powered by it. Every region will build it. Indosat here in Indonesia. Here in Taiwan, GMI. Here in Taiwan, GMI. It's okay to clap. So, incredible companies, incredible opportunity, but all of them need several things. Of course, they need the computing stack. This entire stack underneath. This is what made NVIDIA famous. All of our hardware and software and libraries, our connection into the world's ecosystem of third-party developers makes it possible for anyone to stand up an AI cloud. However, the AI cloud is so complex now. This is the software version. This is the computer science version. The money version, the asset version is what I showed you earlier. It's a giant factory. Having this ability alone is not enough, which is the reason why NVIDIA has become an AI infrastructure company. Now, doing this well and becoming incredibly good at helping customers build AI factories and deploying AI factories is incredibly important. And the reason for that is this. Compute is revenue now. Compute is profit. The absence of revenues and profit is loss. And so it's really important to realize that this is an example of an AI infrastructure coming online. It could be coming online quickly. It could take a while. Its throughput could be high. It could be low. Its resilience and reliability could be good or bad. And its lifetime of usefulness could be long or short. Because this represents 50, 60, going to $100 billion. This curve matters greatly, which is the reason why NVIDIA is such a great partner. Working with us because of our fully integrated capability, we didn't just come up with a PowerPoint slide. We created the entire infrastructure. We connected everything together. We built out billions and billions of it ourselves to make sure that everything works well. As a result of that, our time to first token, our time to first token, our time to first inference, our time to training turned on is much faster. Second, because our throughput per watt, our tokens per watt, is utterly world-class. And the reason for that is because we integrate everything, we design everything from the ground up, we simulate the entire system, and we use extreme co-design. Just like I showed you just now with the Vera Rubin rack, everything was designed in order to deliver on this incredible throughput. If your data center, if your factory has 1 gigawatt, it will not have more. 1 gigawatt means 1 gigawatt. That's all the power generation you could do. If you have 1 gigawatt of power, then throughput per watt is revenues. Because every token is profitable. Every token is revenues. This is the future. Compute is revenues. Performance per watt is your revenues. Choosing the wrong architecture just because the chips are cheaper doesn't translate, doesn't make sense. You need to make sure that your revenues per watt, the more you buy, the more you make. And so tokens per watt. And then lastly, third is reliability. If you ever get a chance to see these data centers, there are so many moving parts, millions of cables. The ability for all of those computers to work harmoniously, reliably, is extremely low. It is just extremely difficult. We have now been operating very large scale for a very long time. That experience matters. That difference, mean time between interrupts, extremely important. And then lastly, this is very hard. The lifetime of these systems, the software is changing all the time. 4 years ago, which is in the time of Hopper, AI has completely changed. 6 years ago, this is the time frame of Ampere, AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers. And then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make. Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard, your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production. Vera Rubin is in full production. The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster, and we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you. Let's take a look.
Large language models generate answers. Now AI agents can do work. But processing agentic AI is a whole different kind of problem. Agents observe, reason, plan, use tools. They manage massive context, juggling working memory and long-term memory. They spin up sub-agents, specialists on demand. NVIDIA Vera Rubin is a multi-rack pod-scale system built to process agentic AI and is now in full production. The manufacturing, automation, and orchestration across the supply chain, a miracle to witness. Our journey started when we launched the first AI supercomputer, NVIDIA DGX-1. Over the next decade, we pushed every chip and system to the limit, from Pascal and the first NVLink to Grace Blackwell, the first rack-scale AI supercomputer. And now, Vera Rubin, the first multi-rack pod-scale supercomputer, built for the agentic age. It starts at TSMC. The 7 new chips that make up Vera Rubin take shape through hundreds of processing steps. 3-nanometer process, CoWoS-R and CoWoS-L packaging, HBM4 memory from Micron, SK Hynix, and Samsung. The Vera Rubin compute board. 6 trillion transistors with over 18,000 components on one board. Vera Rubin NVL72 does the thinking, prompt and context understanding, reasoning, and planning. Next, a new modular compute tray, streamlined with a new PCB mid-plane design, super chips, Connect X9 Super NICs, and Bluefield 4 DPUs, all made in place, with no cables for resiliency at AI factory scale. 18 compute trays, 9 hot swappable NVLink switch trays, new high-efficiency mounts, liquid-cooled bus bars, carrying over 5,000 amps, the equivalent of 20 electric cars at full acceleration. Together, 1.3 million components form this third-generation MGX rack design. Congratulations to Microsoft for their operational Vera Rubin NVL72 engineering rack. Congratulations to Dell and CoreWeave as well for standing up their Vera Rubin NVL72 engineering rack. Then, the Vera CPU rack, 256 CPUs in a single liquid-cooled rack, orchestrating the models, shuffling memory, launching tools. At Foxconn and Quanta, Grok 3 LPS takes shape. 256 Grok 3 LPUs across 16 trays, 40 petabytes per second of SRAM bandwidth for ultra-low latency. While NVL72 generates tokens at the highest throughput, Grok LPX generates them at the lowest latency. Vera Bluefield 4 STX, where AI keeps its memory. Storage processing accelerated by Bluefield 4, connecting memory, storage, and in-silicon security. And NVIDIA Spectrum X Ethernet Photonics, the world's first Ethernet switch with 200 gigabit co-packaged optics, TSMC's COUP process, chip-scale packaging, and ultra-high-powered laser dyes on indium phosphide. Vera Rubin, 5 connected rack-scale systems, a supercomputer for AI agents, 150 supply chain partners across Taiwan, millions of square feet of factory floor, hundreds of sites, chips, packages, systems, and data centers pushed to the limits of size, power, and scale. This is what we call extreme co-design. We did this with Taiwan. Together, we reinvented computing for the age of AI. Taiwan was with us at the beginning, and here today, as we bring Vera Rubin to the world. Thank you, Taiwan.
Ladies and gentlemen, Vera Rubin. Vera Rubin was not just built for AI. Vera Rubin was not built just to run AI. Vera Rubin was built to run agents. This is an agentic system. Imagine the complexity, which is the reason why agents is the last computer science breakthrough. It has taken this many years for agents to realize its potential and become useful. It stands to reason that the computer that runs it is the most advanced in the world. This is Vera Rubin. Let's take a look. Can we bring out Vera Rubin, please? And Janine, do we have the racks, the systems? It looks heavy. This is Vera Rubin. Vera Rubin NVLink 72. This is the Grok LPX. At the next GTC, I'm going to talk to you about a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology all coming together. Now, when we built Hopper, we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we're working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy, we could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 72. Today, NVIDIA's token cost is the lowest in the world. Not by 10%, by X factors, orders of magnitude. All because we did extreme co-design, all because we understood the computing model, the computing pattern of inference, and we were able to create NVLink 72. Now, with Vera Rubin, it is beyond inference. It is now inference in an agentic system. This is Vera Rubin. No cables, no hoses, no fans. What used to take the last time when I showed this to you, we had cables everywhere. The cables were amazing to look at. But now, there's a PCB in the middle, which connects both sides. What used to take 2 hours now takes 5 minutes. The reliability and the resilience of Vera Rubin is going to be off the charts. This is our Vera CPU tray, the most advanced CPUs that has ever been built. I'm going to show you that in just a second. And this is our storage tray. 2 Vera CPUs, 4 CX9, incredible amounts of software. This is our new LPX, LPU30, the Grok system, designed for very low latency inference. The throughput is delivered by Vera Rubin and extended with NVLink 72. If you want to extend that even further, you can have Grok LPUs. Here, we have the Vera Rubin NVLink, the switch tray. This is the switches in the middle, and this is revolutionary. Because of Vera Rubin, because of NVLink 72 and the NVLink switches that we created and invented. And this is our Ethernet switches for scale out. What's amazing is we introduced these 2 systems for Grace Blackwell. These 2 systems were created for Grace Blackwell. And today, NVIDIA is the largest networking company in the world. I'm so proud of the networking team. This is such an incredible enabler for everything that we do. I'm going to now talk to you about the next major industry we're going to be part of. Thank you. Janine? Thank you. Zai Jian. I think there are 2,000 people back there pulling that. Okay, let's talk about CPUs. Vera CPUs. CPUs built for the age of AI. All of the CPUs until now were created for people. We were the users. We were the users. We were the renters. The way we use CPUs, we live in a world counted by seconds. The way we rent CPUs in the cloud, each one of them, more CPU cores you have, the more you can rent. The economics of the use case of the old CPU and the economics of the old CPU, fundamentally different than agents. Agents are impatient. They don't live in a world that is in seconds. They live in a world that's in nanoseconds. When it uses a tool, it wants the response time to be as fast as possible. When it accesses database, it has to come back as soon as possible. Every moment that the agent is waiting keeps it from going to the next step, the next step, the next step. It is vital that we make the CPUs as low latency as possible, as interactive as possible. So we created Vera CPU for the age of AI. Now, inside our system, it's used for 3 different ways. The first way, of course, is Vera Rubin for thinking. And inside the Vera Rubin rack, there are already 2 CPUs. As you know, we are building and selling millions of Vera Rubins. We have sold millions of Grace Blackwells. NVIDIA already is one of the largest CPU makers in the world. In the Vera Rubin rack are 2 CPUs. One for orchestrating and managing the GPUs, managing the KV cache, dealing with all of the software that runs in the rack. We also have the Grace Bluefield that is used for security and isolation. The Vera compute is used for the harness, the orchestration of the AI models, tool use, accessing the database. And the data servers are right here, Vera Bluefield. The fastest storage servers, the fastest storage system the world has ever made. And the reason why this is so vital is because agents are accessing memory so incredibly fast. These systems, the storage server and the CPUs, are now the critical path of the most expensive part of the data center. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up. A CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind. The 4 takeaways. The first takeaway is that the instructions per clock of Vera has to be incredibly good because we need the latency to be short. We need the processing time, single-threaded performance, not throughput, single-threaded performance has to be world-class, absolutely the best. Single-threaded performance, which is the reason why the IPC, The instructions per clock of Vera is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number one. Number two, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world-class. This is the first CPU that's been built a long time that is literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light. 3.6 terabytes per second. No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core, they're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience, because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient, so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? Let's take a look.
Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU, built for the agentic loop, combining NVIDIA's custom data center CPU core with the scalable coherency fabric for the right balance of performance cores and bandwidth to maximize AI factory output. At the heart of Vera is the NVIDIA Olympus core, built for modern data center workloads, branch-heavy Python runtimes, tool calls, and sandbox code execution. Each core is tuned for throughput, A neural branch predictor evaluating 2 taken branches per cycle. A 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data path. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory, while correcting multiple errors simultaneously without compromising bandwidth. Vera achieves 40% lower peak memory latency versus x86, keeping cores fed on time through retrieval, analytics, and sandbox execution. NVIDIA's second-generation scalable coherency fabric unifies all 88 Olympus cores on a monolithic mesh with separate dies for memory and I/O. Cores are not split across chiplets, enabling 50% faster core-to-core communication than traditional CPUs. And memory-coherent NVLink chip-to-chip connects GPUs directly to the fabric. Beyond GPUs, NVLink chip-to-chip can scale Vera up to multiple sockets, enabling massive bandwidth between CPUs. Vera delivers 1.8 times the agentic sandbox performance of x86 CPUs. Standalone Vera racks run agent sandboxes, tools, code, and data pipelines. Tightly coupled to Rubin GPUs, Vera keeps accelerated workflows moving. NVIDIA Vera Bluefield 4 STX powers context memory and AI storage. Compute, networking, storage. Vera is the CPU for the age of agents.
This is going to be our new major growth driver. The reviews are already coming out, and it's pretty good. That's pretty good stuff. Now remember, Grace and Vera are also the most highly qualified CPUs in the world of AI, because every single data center, every single enterprise, every company that works with NVIDIA on AI has already qualified Grace. The entire software stack has already been optimized for Grace. Every company will be qualifying Vera. Vera will be the most optimized agentic CPU in the world, simply because it's going to go with Vera Rubin, simply because we made the big hard switch. In fact, during Grace Blackwell transition, the biggest risk was going from external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell. When people say Blackwell, they say Grace Blackwell, because it is utterly now everywhere. Every company's software stack has been optimized for it. Everybody's security stack has been optimized for it. And now here comes Vera. I'm super excited about that. Now look at some of the performance numbers. Speedups is one thing. It is extremely hard to speed up SQL. SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster. Not 10% faster, not 25% faster, 10 times, 3 times faster. Incredible. This is real-time, the next one is real-time stream processing. Remember, your AI is going to be not just reading documents. Your AI is going to be watching for telemetry, especially inside a factory, inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single-threaded instruction execution, the bandwidth inside between the cores, the bandwidth outside. Vera is completely revolutionary. That's Vera. X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPUs. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up. It's opened up a brand new market. Agents is a new workload. We built CPUs for humans in the past. We need CPUs for agents, agentic systems. The properties are different. Why would the old CPUs be the same? We are building millions and millions of Veras. Millions of Veras. And to go to market with us, Taiwan's ODMs and computer makers, all the OEMs, and you can see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market. CPU for agents. And this market will surely be larger than the last. And the reason for that is because there'll be a lot more agents than there are people, and then the agents are very impatient. So NVIDIA, Vera CPU. Thank you. This is the most important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it. Every company will be an agent company. Every company will have agents running inside. Every company will see that agents will need its own operating system. Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the NVIDIA Agent Toolkit for Enterprise AI. You've seen me build this in plain sight. Almost everything that NVIDIA does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today. This you've seen me talking about for several years now, because we've been building for this moment. There are 4 things that companies need in order to build agents as a service or build agents to operate. The first thing you need is you need models. Of course, large language models. The smarter the better, the cheaper the better, the faster the better. The second is you need a harness to orchestrate the whole thing. The third, these models want to use tools. And these tools come with its skills. And I showed you CUDA-X libraries. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA Toolkit for agents. It includes models that you can modify. NVIDIA's world-class open models, and I'll show you more. You can run agents from anybody. You could run Cloud Code, incredible agent, Codex, incredible agent. You could run it inside this harness called OpenShell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. Its identity is protected. And so this OpenShell is being adopted all over the world. NVIDIA OpenShell is open source. you're going to see so many companies adopt it. Red Hat, Canonical, Microsoft, it's going to be adopted everywhere. This is an important, this is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere. Okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents is chip designers. It is the single most important thing that NVIDIA does. And so, of course, we have to partner with Cadence to build Super Agent, a chip-designed super agent. It is orchestrated by codecs or Cloud Code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents that are optimized for the NVIDIA runtime with Nemotron. And let's take a look. It's really incredible.
Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI models. Designing these chips and the systems they run in is one of the hardest engineering challenges. Trillions of transistors, 3-dimensional circuits, microscopic scale, every gate, every wire, synchronized to picoseconds, must work in perfect harmony, with no margin for error. Physical prototypes are too slow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At NVIDIA, thousands of engineers, billions of compute hours per year, millions of tests, written, run, and debugged. A cycle that takes teams weeks. To compress this cycle, Cadence and NVIDIA built a design verification agent. Codex orchestrates the process. Cadence ChipStack launches the RTL verification loop, powered by Nemotron and secured by NVIDIA OpenShell. Calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The ChipStack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper, design flaws revealed, bugs in the code fixed. What once took weeks now takes hours. Verification cycles over 40 times faster. Together, NVIDIA and Cadence are reinventing chip design with AI agents.
From weeks to hours. From weeks to hours. NVIDIA has thousands of chip designers. We are going to hire hundreds of thousands of Cadence super agents that work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are Cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence, with their proprietary knowledge, they have to start with an excellent model. We call it Nemotron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today we're announcing the Nemotron 3 Ultra. Yep, our next open model. And it is smart. The Nemotron models not only give you the model, we give you all the data that we use to train the model, and because we have a coalition of incredible partners, you can see all of our partners down here, we work together, contribute data to each other. Nemotron is trained on one of the largest suites of long-running reasoning models, long-running task-solving, tool-using data sets in the world. Because of all of our great partnerships, all of this from the model, the training script, and the data made completely available to you. This is open models at its best. The best open model system policies in the world. Simple goal is so that you can take all of it, add to it, make it even better, make it yours. Nemotron 3 Ultra is 5 times faster. This is the world's first model based on a hybrid architecture of SSM, state-based models, with mixture of experts. The architecture is incredibly fast. We made it fast so that you could think fast. When you think fast, you could think longer at the same cost. So 5 times faster. It is also 30% cheaper. 30% lower cost to run in total flops and total inference time than even the most cost-effective in the world. We're comparing against the world's best open models. Frontier Smart, 5 times faster, 30% cheaper, completely open. We're completely dedicated to this. This is now Nemotron 3. We're currently working on Nemotron 4. So this entire toolkit, from models, harnesses, tools and skills, and runtimes, is the reason why every enterprise company in the world has the ability now to create their own agents, just like Cadence did with their super agents. And we're working with so many companies, Cadence and CrowdStrike and Dassault and Palantir, SAP and ServiceNow. People were always said, Jensen, the agents are going to disrupt these markets. I said completely opposite, and you can now see it. Agents is going to create the largest opportunity ever for my partners and friends. And we have the NVIDIA Agentic Toolkit for enterprise AI to help them. So, there you go. First, Vera Rubin in full production. 2, Vera CPU built for a new generation for agents. And 3, NVIDIA's enterprise AI toolkits, so that every enterprise and every enterprise software company can build agents. My relationship with you started here. And many of you, many of my friends and partners here in Taiwan, your companies started here. This is, in a lot of ways, the beginning of the modern computer industry, 40 years now. NVIDIA is 33 years old. The PC industry was already starting to get to Windows 1 and Windows 2 and Apple 1 and Apple 2. And by the time that we came along, Windows 3.1 was the PC. And as you know, Windows 95 made PC personal. It took PC from enterprises, companies, and made it into a consumer electronics device. Everybody should have one, and everybody does. This is the beginning. This computing platform did several things incredibly smart. Windows was not just disaggregated, as you know. Windows was properly abstracted. It was architected just right. Systems BIOSes, open chipsets. The operating system with drivers that could be connected and installed at runtime. And an abstraction layer with a multimedia API that opened up the PC to what we all know today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya. We're going to talk a lot more about the work that we're doing together. Microsoft and NVIDIA, over the last 3 years, it took this long to completely reinvent how the PC is going to work so that we could be ready for this moment. As I mentioned earlier, that compute pattern called the agent is going to run in AI clouds. It's going to run inside enterprises. It is also going to run on your PC. What's going to happen to that PC when it has an autonomous agent? An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you, do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. Our personal AI, sandboxed for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark. Everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek, fused by NVLink. 128 gigabytes of unified memory, TSMC 3 nanometer process, 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer. For creating, for gaming, for agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
Here it is. Of course, I got to show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him. Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now, thank you. I've too many things in my pocket. 太多东西了。 Okay. All right. This is the most amazing chip the world has ever built. This is the N1X that we built in partnership with MediaTek. I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that frankly would take 33 years to build. And the reason for that is because 100% of NVIDIA software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. If you want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created, and every single application that Windows has ever run. Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it. Okay. Now, I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Supermodel, or it could have Claude Code or Codex or some other model in the cloud or something on the network, and it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness connected to Claude Sonnet in the cloud. I select the site, share my concept sketches and mood board of styles to inspire my design, and the prompt, a text description of the requirements and the design intent. My agent goes to work. Using the tools on my laptop, it opens Rhino and starts modeling the site, shaping terrain, setbacks, and the building envelope. Then it proposes building forms, optimized for cost, comfort, and quality. With the form defined, my agent generates the interior layout. Walls, circulation, rooms begin to take shape. I jump in whenever I want, to adjust, to change. Doors, windows, and structural elements are placed automatically. My agent detects its own mistakes and fixes them. When I approve, the agent exports the model from Rhino into Blender. Materials and object properties transfer with the design context intact. I fine-tune the materials, get the look just right. Then I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent, working with on RTX Spark. Design at the speed of imagination.
He's seeing the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they're going to release it for RTX Spark. It is twice as fast. It's already fast. Now it's going to be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically everybody. Everybody will support RTX Spark and will be building incredibly smart and powerful and beautiful laptops with all of us. Thank you very much. But that's not all. That's not all. RTX Spark is a reinvention of laptop. But in fact, Microsoft NVIDIA is reinventing all of PC. And today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that runs, that you see that runs on NVIDIA and all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours. Okay. Look how beautiful it is. This agent could run 24/7, meter free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's in here, connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this, and this becomes your personal AI, your personal AI agent. And it gets smarter and smarter and smarter over time, because today we have Nemotron 3 Ultra. Tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we'll just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I am certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool where you launch applications, click and type. And this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, or many houses have home theaters, big TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And it's running all of your agents, it's running all of your assistants. And they're doing all kinds of things for you all the time. And you have to have it in your house, just like you have a home theater in your house, you have stereos in your house, you have game consoles in your house. You would assist AI agent computers running in your house. And these, in time, becomes a lot more like R2-D2 to you. it becomes more like C3PO to you than it feels like a PC to you. There is no question this reinvention of the computer is as big of a deal as the reinvention of the phone into what we now know as the smartphone. And so this is the beginning of that journey. This is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I'm just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. A new line, a new beginning. Thank you. As you know, agentic AI is just a digital robot. It understands, it reasons, it plans, and it acts and uses tools. Agentic AI is going to run across all of these computers. And you've seen me talk about each and every one of these over time. We're working on human or robotics computers. Robotics computers of all kinds. We're working on self-driving car computers. We're working on satellites. You have GeForce, which has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we trained on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perception, the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning verifiable rewards. Okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person, and now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we're announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There's so many people working on it. However, in physical AI, we are absolutely the world's best. I am so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3, that can understand and reason, it can generate, it can simulate in the loop, it can even be the policy itself. It is on the top of leaderboards all over the world. I am incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni-model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future, frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher generated by compute. Cosmos, the foundation for developers of the age of physical AI.
It takes data plus compute gives you AI. Now that we have AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open the model, we open the data, and we even open how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most, of course, the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI, agentic robot, that is an autonomous vehicle, has also this complicated stack. Today we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime, with the Halos operating system, we will be able to connect to all of these services across the world. Let's take a look at this.
Hey Mercedes, let's go to my favorite sandwich shop.
Routing to your destination. Lane is clear, pulling out to start drive. Nudge left due to the stationary lead vehicle ahead blocking our lane. Slow down to stop at the stop sign, controlling the intersection. Stop to yield to pedestrians since the person is in our lane. Yield to the cut-in vehicle from the left. Nudge left to clear the stopped vehicle blocking on the right. Keep distance to the cut-in vehicle since it is merging into our lane. Nudge left due to the stopped van blocking the right side of our lane. There is a pedestrian crossing ahead. Stop to keep distance to the lead vehicle. Keep distance to the vehicle directly ahead in our lane. Keep distance to the vehicle directly ahead in our lane. Stop to the stop sign since the intersection is controlled. Stop to yield to the cross traffic since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge right due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Nudge left due to the truck blocking the right side of our lane. Your destination is on the right.
Alpha Mayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpha Mayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GR00T is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GR00T platform, the Isaac GR00T platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human or robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today we're announcing the NVIDIA Isaac GR00T, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot. 6 feet, 150 pounds. Just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac GR00T, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos. Scaling one demonstration into thousands. Train policies. Evaluate them in Isaac Lab Arena. Deploy through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. GR00T is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac GR00T reference design robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, and anywhere. The age of robotics starts here. NVIDIA Isaac GR00T.
So many robots. We're working with just about everybody who's working on robots in the world, or robotic systems in the world. Let me tell you what I told you. The computer industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent, that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You will use different models because of your preference. You will improve them for your proprietary use. You will create super agents that you can rent to other people to help them do their work. This agentic platform, this agentic pattern, NVIDIA has an enterprise AI toolkit. This is a wonderful way for all of you to engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is an entire disaggregated, distributed agent processing system. NVIDIA has really become an infrastructure company. Not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs. But in the future, it'll be robots and satellites and base stations and factories in the cloud, on-prem, at the edge. This pattern, agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I am so proud of how you've been so successful this last year. The next year is going to be even more. I have one more thing for you. Let's take a look.
Gonna break it all down for you, Taipei.
Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms. But they need so much compute, we hear ya. That's why we created Vera.
Rubin stole the show, it's true. The cheapest tokens coming through.
10 times faster inference heaven. More special agents than 007.
Bluefield keeps agents' memory true.
Now talk about a CPU.
50% faster, that's outrageous.
Not for Vera.
It's built for agents. NVLink Fusion blends E6 smartly.
Everyone's welcome to the NVLink party.
Well, if you like that introduction,
Vera Rubin in full production. Neutron Ultra leads the run. 5x faster work gets done. Need more cars with the guardrails right. Open shell keeps the sandbox tight.
your code migrated and reviewed.
Before this song is through.
It's a 5-layer cake.
while ESX keeps powering, connecting dots.
Every watt optimized for you,
So you can have your cake.
you can eat it too.
RTX is finally here.
Biggest PC moment in
40 years. Agents powering our workflows. Running anywhere Windows go.
harnesses run on CPU.
Models fly on GPU.
Cosmos builds worlds that robots need.
Turning compute into synthetic feed.
Our POCs and reasons through.
Understands roles like people do.
Who is how to learn to move.
Learning skills and finding growth.
Geometries powered by Thor.
The future's humanoid. The future's bright. Come see what's next.
Thank you, Taiwan.
Welcome to Computex.
大家谢谢。Have a great Computex. 大家谢谢. Thanks for an amazing year. Thank you for all your friendship and support. Thank you. Take care. Have a great Computex.
Woke up feeling something shift. Same room, but the air felt it. Mirror said I'm still that kid. I said you're bigger than this. Tie my laces, hands still shook. First step was the hardest one. Every lap, every sideways look, all fade when the race is run. I carried every doubt lightweight. Now I'm lighter than the flame. You can write it on the.
先切罐，然后他们扫 QR code，然后你那边就可以直接处理了。要吗？
好的，那大家听完 Jensen 的精彩分享，相信大家一定非常收获满满吧。OK， 接下来我们即将进行就是大家今天最期待的抽奖活动哦。然后现在呢，我们要投影画面，现在可以看到这个 QR code， 请大家尽快的扫描，并且填写抽奖资料。然后大家在填写资料的同时，有几个关于抽奖的注意事项必须来提醒大家。第一个呢，就是待会被抽中的幸运儿本人必须在现场，并且完成我们现场的拍照打卡上传的任务，才有资格抽奖。奖项抽出我们会唱名3次，如果唱名3次本人没有在现场，就视同放弃中奖资格。奖项抽出后，我们会唱名3次。OK。第二点说到，中奖人除了本人要在现场外，还要当场出示你的身份证件，并且依现场工作人员指示完成填写中奖单。若无法当场出示身份证及学生证，或填写资料与身份资讯不符的人，也视同放弃中奖。所有中奖流程皆由本人亲自办理，不接受代领。最后的提醒，若中奖奖项价值超过新台币2万元，中奖人需现场汇款或现金缴交10% 的机会中奖税金。非中华民国国民之中奖人需缴交20% 机会中奖税金。不愿意配合者也视同放弃中奖。 那我们还有3分钟可以填写哦。大家都有记得带证件吧？都有哦，任何人都是有可能的哦。最后1分钟。你们紧张吗？紧张哦。都上传拍照打卡了吗？都打卡了吗 ？OK， 记得要 hashtag 哦，一定要 hashtag。倒数30秒。QR code 的画面及抽奖券的渠道即将关闭，还没有填写或是完成的人要加快速度喽。好，我们抽奖渠道关闭了。好，我们再次提醒，有几个关于抽奖的注意事项。第一，待会抽中的幸运儿本人必须在现场，并且完成现场拍照打卡上传的任务。然后我们会唱名3次，若本人不在场，视同放弃中奖资格。第二，中奖人本人在现场之外，还要出示身份证件，并且依照工作人员指示完成中奖单，不接受代领。第3点，特别提醒，将中奖奖项价值超过新台币2万元的，需要缴交10% 的机会中奖税金；非中华民国国民之中奖人需缴交20% 机会中奖税金。不愿意配合缴交者，也视同放弃中奖。OK。那我们要开始咯。第一个呢，我们要先来抽 ASUS 的组合包，你一个人就可以有4个背包，你可以送你的好朋友啦，哈哈哈哈哈。有侧背、单肩还有双肩，所以很多用途。恭喜方欣同学上台，方同学，那么有请图资长上台。其他人你们还有机会显卡哦，显卡哦，对。我们掌声鼓励，恭喜，不是恭喜，对，恭喜方同学。他的朋友赶快去找他， 他的朋友，等下赶快帮他拿。方同学应该很开心吧？耶，可以保护好你的笔电。恭喜！好，请下台找工作人员。好的，我们先来到第2个奖项 ，NVIDIA GeForce RTX 5070创始版显示卡，一样请我们的图资长，对。是谁呢？王佑敏同学，王佑敏同学在吗？赶快到台前，恭喜你！同学看起来好冷静哦。同学怎么这么冷静？对，比较小颗。大家还有最后一个哦，还有那个5080哦。哦，对，要验证，好，好，等他一下。你们期不期待？期不期待最后一个？你们觉得你们自己有没有机会？怎么只有一个同学？你们觉得自己有没有机会？你，大家都好冷静哦。好，请同学上台。耶！请掌声鼓励，恭喜我们的同学。好的，可以下台找工作人员。没关系，你可以先放在里面，等下再拿。对。对，他这个那个不用汇款，金额不到2万。好喽，到我们的压轴喽 ，NVIDIA GeForce RTX 5080创始版显示卡。是谁呢？是谁？陈瑞和同学，请到台前，尽速带着你的证件哦。陈瑞和同学带着证件到台前。到这里找工作人员。同学，你为什么这么冷静啊？哦，超乎想象啊！刚刚拿到显卡的同学，您要拿着显卡做什么呀？刚刚那个拿显卡的同学，还在这。好。我们那个方同学先留在这，等下进行合照。你可以拿一个包包当代表就好。好，请同学先到台前。图资长。 好，请3位得奖同学到台前，我们拍个合照。
我要验牌。
3个同学先拍合照。对，你们先在这里拍个合照。对。好的，恭喜以上得奖得主。我们今天 GTC 台北2026 NVIDIA 黄仁勋执行长主题演讲直播校园派对圆满落幕，感谢大家的参与。散场时请统一由这一个门离开。若需要领取餐点，请依场外人员引导排队并出示餐券领餐。大家再见，拜拜。好。